Dear all, in this second part of this video, we are going to discuss about various concepts of basics of metrology, like methods of measurement, precision, accuracy, and other advancement and applications of metrological and measuring tools. So, in the previous two videos, we have been discussing about various aspects of metrology and measurements. In the first video, I have given the outline of metrology and measurements and its applications and a wide area of utilities of these measurement techniques. In the second video, I have given basic concepts of metrology. There we have been discussing about importance of metrology, significance of the inspection of metrology, concept called accuracy and precision, and general measurement concepts. What is the necessity for doing the inspection? All those things, and we have been discussing, and we also outlined about methods of measurements like direct method, indirect method, comparative method, substitution, null method, and fundamental methods. In the second video of first unit, that is unit 1 part 2, we are going to discuss about units and other basic metrology concepts. So normally the unit is playing the vital role in decision making, whether it is industries or medicine or aerospace or marine or whatever the field of engineering or field of medicine. We need the unit of measurement. We have come across various units. Here just I am going to brief about the 7 fundamental units. Like length, we are measuring using the meter. Time, we are measuring by using seconds. Current, we are measuring by the unit ampere. Temperature by means of Kelvin. Substance, we are measuring with the help of mole. Luminous, the light brightness, dullness, we are measuring using candela. And mass, we are measuring with the unit of kilogram. These are the 5 fundamental units of measurements. As I mentioned here, length symbol is meter, mass symbol is kilogram, time symbol is second, S small s, electric current capital A, temperature capital K, and amount of substance mole, and luminous CD. Yes, there are 2 types of readings we can take, analog and digital. Earlier days we had analog watches and digital watches. Now also we have both equally. Children are preferring digital watches. Elders are preferring analog watches. Now the watches have come out with different applications like heartbeat measurement, temperature measurement, amount of calorie burned while walking, and the distance of walking, climbing steps. All those things are coming in the watch if you type in the wrist watches. So analog and digital instruments, physical variables, we are measuring using digital as well as analog. Active and passive instrument. So if you look at this slide, we can easily understand active measurement. It requires some additional power, auxiliary power it needs. Whereas for passive, by quantity being measured, like pressure gauge, Bourdon pressure gauge. This is the output from the measuring instrument is purely by the quantity being measured. So this is the difference between active and passive instruments. Automatic and manually operated, we have come across this type of weighing machine. And the contact and non-contact type, that too during the COVID and pandemic situation, we have very familiar with this type of measuring instruments like temperature measuring instruments, thermometer, and non-contact type thermometer. The unit of measurement of temperature is Kelvin or degree Celsius. Absolute instruments by means of deflection. This is a old method. Since we are not using often, it doesn't require any calibration. Example, galvanometer and electrometer. Secondary instruments to measure the voltmeter, we need ammeter, voltmeter, ampere hour meter, wattmeter, etc. Output is measured to give the value of the quantity. Based on the deflection in these instruments, that is a needle deflection will be there. By looking at this, we are measuring how much amp or how much volt. All those things we can measure. Absolute measurements are used in laboratories, where secondary measurements are used in everyday work. That's the difference between absolute and secondary. Absolute measurements are used in laboratories. Secondary instruments are used in everyday life. This is called intelligent measurement. If it is incorporated with microcontroller sensors, it will become intelligent. Nowadays, we are talking about artificial intelligence, evolving technologies. If microcontroller chips and sensors are implanted, then embedded, it will become intelligent instruments. And if you come to the characteristics of metrological measuring instrument, range is one of the important characteristics. This indicates the minimum and the range between minimum and maximum value. So by using this steel rule, for example, 1 centimeter, minimum 1 centimeter and maximum 30 centimeter we can measure. That is the range, 1 to 30 centimeter. We could not measure 35 centimeter. In the 1 foot scale, we could measure only up to 30 centimeter. Repeatability. If you keep on measuring again and again and again of the same quantity with the same instrument, that is called repeatability. Reproducibility is consistent measurements. If you are getting the same measurement, that is called consistency, that is reproducibility. Accuracy. This is called closeness of instrument output to the true value of the measured quantity. If, for example, true value, if you are measuring 20 mm, means if you are getting the same 20.1 or 19.99, that is called accuracy. Whereas the precision is defined as the ability of the instrument to reproduce a certain set of readings within a given accuracy. Precision depends upon the instrument. Accuracy, it is depend upon the repeatability. This is the difference we got to understand. Sensitivity, another important term we have, that is variation of readings. Change in the output reading for a given change of the input. It is a scale factor, large movement of the indicator for a small input change. Sensitivity, if you look at the graph, we can measure the sensitivity. Force, we can measure using the load cell. And readability, how we are taking the measurements or readings from the given measuring tool. This is called readability. Accuracy, we have discussed the extent to which the measured value agrees with the true value, that is called accuracy. Quality confirmation. So this is the precision that is based on the instrument. along is this block that is of the same length. That is called precision. Accuracy versus precision. The first diagram shows high accuracy and high precision since all the values, repeated values are falling in a single point. Last one gives low accuracy and low precision. It varies, is scattered. This is called low precision.